So, what we want to discuss today, the three rules that we want you to know. That's one. Okay. The bus seat rule. The the Pauli exclusion principle. Okay. So those are the three things that we're going to be looking at today. We've used two of them already. You just didn't realize that. Okay. So you don't need to write this down. Just know more what it actually means. So I want to make sure I get this spelled correctly. Okay, Pauli exclusion principle. Okay, so what I want you to think about is we're going to do the elements aluminum, sulfur, phosphorus. I said that wrong. Aluminum, silicon, phosphorus, and sulfur. And we'll illustrate what we mean by that. Okay, so we got aluminum, number 13. Okay, so we'll just, let's see here, silicon, 14. Then we got phosphorus, which is 15. And then finally, what was it, sulfur, yes, 16. Okay, so what we'll do is N, L. We can't quite see it, I'm too far over. Okay. I'm going to have to move them all over just a little bit. Okay. And then we'll get rolling on a video we were talking about. Okay, aluminum, 13. Silicone, 14. Phosphorus, 15. And then sulfur, 16. Yep, now we can see all of them. So, again, just picture this kind of like a spreadsheet. We've got N equals L equals M equals N. Oops, not N. S. Okay? Now I think those are in the frame of view just barely. Okay, so we don't necessarily have to go in order. Just go ahead and pick one. Phosphorus, okay, that's the first one that I heard. Okay, so you can skip all of the orbitals except for the last one where that electron falls into. So with the knowledge that you have utilized so far with your periodic table, which period is phosphorus in? The only one we really got to be concerned or careful with is D block elements. This is not a D block or transition metal. So with that, okay, I heard it. What was it? Okay, so I'll just put that above here. So how many horizontal lines do we use for phosphorus then? Since it's in the P block. Okay, because the P block can hold how many? It can hold 6, okay? So 3P. Now, what column in the P block only is phosphorus in? Okay, so now we're practicing Hund's rule, which means we got 3 bus seats here. So how do these 3 electrons fill these 3 seats? One at a time. Up, up, and up. Okay? So there should be 2 of the quantum numbers we know right away. Okay? So since it's in the 3rd energy level, which variable is that? N equals 3. Okay? Okay? Well, let's just go in order. Okay? But you're right. Okay? So then the next one, since it's in the P block, what value does L have then? Okay. What other numbers could it possibly be? 0, 1, 2, or 3. So we said 1. So then how do we get the value for M then? Without skipping over. Okay. Is this getting to be a little easier to deal with the more examples that we do? Okay. So again, this comes from the idea that M equals a positive L to a negative L. Well, we've established what L was. It's 1. So putting that variable in, that means it is, well, I got them backwards, a negative L to a positive L. Okay, so that means we would go -1, 0, +1. So that last one is in which subshell? +1. And it's pointing up. So S is what? Okay. Go ahead and pick another one. Silicone. Okay. So P block element, 6 columns. What column in the P block is in the second one? So that means this is up, and again, don't start pairing these until what happens? Until all the bus seats are full with one occupant, then you put the second one in there. That's Hund's rule or the bus seat rule. So what's N? 3. What's L? 1. What is M? 0. And what is S? I'm sorry, what's that? Yeah. This right here. It's the period. The period. Yes. Yes. Right, and that's where this comes from, because silicone is in the second column of the P block. Okay, phosphorus is in the third column of the P block. Okay, so we got 2 down, 2 to go. Yes, it would be 3P2. Yep. Next. Okay, so there again, how many electrons, what column is aluminum in the P block? 1. Okay, there it is. So what is N? What is L? What is M? And what is S? Okay, so now we've got 3 of the 4 done. Finally, what column is sulfur in the P block? 4th one. Okay, so again, let's follow our bus seat rule. We don't want to do this. That is incorrect. You cannot have an empty bus seat when you have this many electrons. So again, that's Hund's rule, that an electron must occupy a subshell before it can be paired up. So we said 4, up, up, and up. How many are left? So he gets paired up that way. So N, L, 1 or -1? Okay, M and S. There we go. Okay, so as we look at these, okay, The Pauli exclusion principle says that no two elements can have the same four quantum numbers. So as you look at this, obviously all four of them have n equals 3, because that last electron falls in which energy level? The third one. Okay, so this might get to be a little cluttered, my apologies, but let's look at silicon, for instance. We know we got 15 protons in the nucleus. Now we're using Afabou's principle or the slide rule. So how many? 1s what? 2s2, then what? 3p, 3p, oh, I wrote the wrong number, I'm sorry. That's why. Okay, I was just seeing if you were paying attention. Okay, so then this 2 right here is these 2 electrons right there. Here's your third energy level. That's where this 3 comes from. Okay, so again, this is kind of from the Bohr model. It's telling you which energy level it is. This is a given number. Excuse me, table 1 on page 108. Okay, so it's assigned as S is 0, P is 1, D is 2, F is, okay, so up to this point, is anybody, I don't get this. Because if you don't tell me, then we got to figure we're with it so far. Good, good, good. Except for D block elements, you got to be careful with those. You got to subtract 1, yes. Okay. So, again, the energy level tells you N. This is given. It's assigned by table 1 on page 108. We want you to know that. This comes from which orbital, which subshell that fell into. It's assigned by the positive and negative values of this. So just like we put -1, 0, +1, we would do the same thing here. -1, 0, +1. It fell in the 0 block. That's why that is 0. Correct. Yep. So notice how many electrons you have up here. They're all next to one another. That is increasing by an increment of 1. They're all in the third period. They're all in the D block. This is in the first column of the this is the first column of the P block, the second column of the P block, the third column of the P block, and then the fourth column of the P block. That's why there's 4 there. Okay? So these numbers are all the same for each one of these. But then notice it starts to rotate. -1, 0, +1, -1 again. So each one of these is the exact same with what we see here. This and this one, with the exception of what number is different. It's the spin. So no matter which element you look at, they cannot have the same set of 4 quantum numbers. Pauli exclusion principle. I just wanted to pick something small that we could get through that fairly quickly. So assigning these. Remember, the first time that you had seen this, do you think you've come a little ways since then? Okay. All right. And that's what we would hope, that's what we would expect, and that's what we are again, hoping for. So, what we want to do is maybe look at, well, where did all this information come from? Well, part of it comes from Albert Einstein, part of it comes from Niels Bohr, and that's why we'll call it the Bohr model. So, we will observe this for the next amount of set of time. We'll finish it tomorrow, and then I will have that to paper for you. Okay, so hopefully that picks up the sound. I think it does fairly well. So, is there any questions over this before I pull down the screen? Okay. How many of you wrote this information down? Down? Yeah? All right. So, it's one of the things, keep in mind, we're writing this information down for be doing what? Pointing down.